When dealing with a 4000 amp 480/277 volt 3-phase 4-wire bus Weatherhead that feeds multiple main disconnects, it's crucial to understand the grounding requirements for each main. The National Electrical Code, or NEC, dictates that each main disconnect requires its own separate grounding electrode conductor. This means that a 300 amp main, and each of the 3 additional mains that will be added, will not share a single grounding electrode conductor sized for 4000 amps. Instead, each main will have its own grounding electrode conductor, sized according to the amperage of the specific main disconnect. The size of the grounding electrode conductor is determined by NEC Table 250.66, which relates the size of the service entrance conductor to the required size of the grounding electrode conductor. To determine the appropriate size for each grounding electrode conductor, you first need to determine the size of the ungrounded service entrance conductors for each main. For instance, if the 300 amp main has service entrance conductors that are sized as 3/0 American wire gauge or all copper, you would refer to NEC Table 250.66 to find the corresponding grounding electrode conductor size. According to NEC Table 250.66, a 3/0 AWG copper service entrance conductor would require a minimum of 4 AWG copper grounding electrode conductor. It is important to consult the current version of the NEC and any applicable local amendments to ensure compliance with the latest regulations. The purpose of a grounding electrode conductor is to provide a low impedance path for fault current to return to the source, allowing overcurrent protective devices like circuit breakers or fuses to operate and clear the fault. This helps to prevent electrical shock hazards and minimize damage to equipment. Installing a separate grounding electrode conductor for each main disconnect ensures that each service has its own dedicated path to ground, enhancing safety and reliability. The grounding electrode conductor must be connected to a grounding electrode system. This system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or a metal underground water pipe. The NEC specifies the requirements for grounding electrodes in section 250.52. A common grounding electrode system involves driving 2 ground rods that are at least 8 feet long and spaced at least 6 feet apart. The grounding electrode conductor is then connected to both ground rods, providing a redundant grounding path. Another acceptable grounding electrode is a metal underground water pipe that is in direct contact with the earth for at least 10 feet. If a metal water pipe is used as a grounding electrode, it must be supplemented by an additional electrode, such as a ground rod or ground plate. This is to ensure that the grounding system remains effective even if the water pipe is disconnected or replaced with a non-metallic pipe. The connection of the grounding electrode conductor to the grounding electrode must be made using listed connectors or clamps that are suitable for the purpose. These connectors must be securely fastened and protected from corrosion. In addition to the grounding electrode conductor, each main disconnect must also have an equipment grounding conductor. The equipment grounding conductor provides a low impedance path for fault current from the metal enclosures of electrical equipment back to the service neutral. This helps to ensure that any fault current will quickly trip the overcurrent protective device, minimizing the risk of electrical shock. The size of the equipment grounding conductor is determined by NEC Table 250.122, which relates the size of the overcurrent protective device to the required size of the equipment grounding conductor. For example, if the 300 amp main disconnect is protected by a 300 amp circuit breaker, NEC Table 250.122 would specify the minimum size of the equipment grounding conductor. The equipment grounding conductor must be installed in the same raceway or cable as the circuit conductors. It must be connected to all metal enclosures boxes and equipment grounding terminals. It is crucial to properly bond all metal parts of the electrical system to the equipment grounding conductor to ensure a continuous low impedance path for fault current. Bonding is the process of connecting all metal parts together to create an electrically conductive path. This can be achieved using bonding jumpers, bonding screws, or other approved methods. Improper grounding and bonding can create dangerous conditions that can lead to electrical shock, fire, and equipment damage. It is essential to follow all applicable codes and standards when installing and maintaining electrical grounding systems. In summary, when installing multiple main disconnects from a single bus to Weatherhead, each main requires its own separate grounding electrode conductor. The size of each grounding electrode conductor is determined by the size of the service entrance conductors for that specific main disconnect, as specified in NEC Table 250.66. Additionally, each main disconnect must have an equipment grounding conductor, sized according to NEC Table 250.122 to provide a low impedance path for fault current. Proper grounding and bonding are essential for electrical safety and should always be performed by qualified personnel. Furthermore, it's important to consider the location of the grounding electrodes. Ideally, they should be located as close as possible to the main disconnects to minimize the length of the grounding electrode conductors. This helps to reduce impedance and improve the effectiveness of the grounding system. In some cases, it may be necessary to install supplemental grounding electrodes to achieve the required grounding resistance. The NEC specifies the maximum allowable grounding resistance in section 250.53. If the grounding resistance exceeds this value, additional grounding electrodes must be installed until the resistance is reduced to an acceptable level. The grounding system should be periodically inspected and tested to ensure that it is functioning properly. This can be done using a ground resistance meter, which measures the resistance of the grounding system to earth. Any problems with the grounding system, such as loose connections or corroded electrodes, should be corrected immediately. It is also important to keep the grounding electrodes free from obstructions and vegetation. Over time, vegetation can grow around the grounding electrodes and interfere with their effectiveness. By following these guidelines, you can ensure that the electrical system is properly grounded and that the risk of electrical shock and fire is minimized. Remember to always consult with a qualified electrician or electrical engineer for assistance with any electrical work. Understanding the specific requirements for grounding multiple mains from a single Weatherhead involves several key aspects, including the NEC requirements, sizing of grounding electrode conductors, and the importance of proper bonding. Firstly, the NEC, particularly Article 250, is the primary resource for grounding and bonding requirements. It outlines the rules and regulations for ensuring electrical safety and proper functioning of electrical systems. When dealing with multiple main disconnects from a single Weatherhead, it is essential to adhere to the NEC guidelines to maintain compliance and safety. Secondly, determining the size of the grounding electrode conductors is crucial. According to NEC Table 250.66, the size of the grounding electrode conductor depends on the size of the service entrance conductors. For each main disconnect, the grounding electrode conductor must be sized based on the corresponding service entrance conductors for that specific main. This ensures that each main has an adequate grounding path to handle potential fault currents. Thirdly, proper bonding is essential for electrical safety. Bonding involves connecting all metal parts of the electrical system together to create a continuous, low impedance path for fault currents. This helps to minimize the risk of electrical shock and equipment damage. Bonding should be performed in accordance with NEC requirements and using appropriate bonding methods and materials. In addition to these key aspects, there are several other considerations to keep in mind when grounding multiple mains from a single Weatherhead. These include the type of grounding electrodes used, the location of the grounding electrodes, and the overall design of the grounding system. Grounding electrodes can include ground rods, ground plates, or metal underground water pipes. The choice of grounding electrode depends on site conditions and local requirements. The location of the grounding electrodes is also important. They should be located as close as possible to the main disconnects to minimize the length of the grounding electrode conductors. This helps to reduce impedance and improve the effectiveness of the grounding system. The overall design of the grounding system should take into account the specific characteristics of the electrical system and the building or structure it serves. This includes factors such as the size and type of loads, the voltage level, and the presence of any sensitive electronic equipment. A well-designed grounding system can help to protect against electrical shock, fire, and equipment damage. In summary, Grounding multiple mains from a single weatherhead requires careful attention to detail and adherence to NEC requirements. By properly sizing grounding electrode conductors, ensuring proper bonding, and considering the specific characteristics of the electrical system, you can create a safe and reliable grounding system. Remember to consult with a qualified electrician or electrical engineer for assistance with any electrical work. They can help you to design and install a grounding system that meets your specific needs and ensures compliance with all applicable codes and standards. When working with electrical systems, safety should always be the top priority. Proper grounding is essential for electrical safety and should never be overlooked. By following the guidelines outlined in the NEC and consulting with qualified professionals, you can ensure that your electrical system is properly grounded and that the risk of electrical hazards is minimized. In conclusion, each main disconnect from a bus weatherhead necessitates its own dedicated grounding electrode conductor, sized according to the amperage of the corresponding service entrance conductors. This approach, guided by the NEC, ensures individual protection and a robust grounding system for each service. Attention to bonding, grounding electrode selection, and overall system design further enhances safety and reliability. Consulting with qualified professionals remains paramount for proper implementation and adherence to evolving electrical codes.